Okay, so now what we're going to do is find the future value of $100. And we're interested in that $100, what it would be after 3 years, because that's the proposition that's been made to us. It's this comparison between the 100 and 105 in 3 years. If we take the 100 now, we could put it into something and it could earn interest. And what would it be worth after 3 years? If it's worth less than 105, then surely we should take the 105 in 3 years rather than take the 100 now. If it's worth exactly 105, we're indifferent. We could go either way. If what we could get on our $100 would amount to more than 105 in 3 years, we should take the $100 now, put it into something, and in 3 years we'll have more than we would have had if we held out for 3 years to get that $105. In other words, we can get a better rate of return than the rate of return the person making you this offer is giving you. So let's explore how we're going to get there. How can we figure out what $100 deposited now will be worth in 3 years? Well, of course, you're probably thinking, well, that depends on the interest rate. Yes, it does. So most of the time in textbooks and on these videos that you find on the YouTube and places, they assume an interest rate like 5, 6%, stuff like that. Well, let me tell you, you and I don't have access to risk-free savings or investments, personal investments, that yield 5 and 6%. Those numbers are just not realistic in today's economy. So I looked. Currently, the interest rate available to me and you that is risk-free, the best I could find, the best I know of, it doesn't have high transaction costs to get involved with anyway, is 0.65%. That's 65 basis points, 65 hundredths of a percent. Nowhere near the textbook examples. That's what Ally Bank pays on a 3-year certificate of deposit, or a CD, at the time that I did this. Ally Bank has the best rates of bank that I know of. I've looked that up, best rates and stuff like that. Every time I've looked, they're always in the top 10, and they don't charge any fees or anything like that. They're not a brick and mortar bank; they're an online bank, so they have lower costs, so they can offer higher rates than Wells Fargo or Bank of America, who have buildings that and more employees that they have to pay for. They're not automated like Ally Bank is. So that's a good rate right now, 0.65%. So you take your $100, you set up an Ally Bank account. That takes about 15 minutes, and that's what you can expect to get. And that's risk-free. You could put it in the stock market, but that is not risk-free. So it's not comparable to our scenario where a person's offering you $100 now or $105 in 3 years, and this person is a reliable person. We want to keep it consistent with the scenario. So we need to put it in a reliable instrument. Certificate of deposit, it's insured by FDIC, it's safe, it's risk-free, and that's what you can get. You might like to hear you can get more. I'm just here to tell you, you can, but not without accepting higher risk. So, what's this $100 going to be worth if you take it today and put it in a CD at Ally Bank? Well, the first year is easy. If it pays 0.65%, 0.65%, convert it to a decimal. You move the decimal over 2 places to convert to a decimal. That's 0.065. 0.0065. 0.0065. It's not even a full percent. So we could take 100 and multiply it by 0.0065, and that would give us how much interest it would make after the end of a year. Or we could probably just do it in our heads. Because after a year, what would 1% interest be on $100? Think about that for a second. 1% interest on $100 would be $1. But we know 0.65 is less than 1%. So it would be 65 cents. So at the end of the year 1, you will have made 65 cents in interest. So what will the balance be? It'll be that principal amount of 100 plus the interest that you made in the year, $100.65. That's how much you could expect to have at the end of the year. And I can do that without using my dry erase board and my marker here, because that's pretty simple mental math. But after that, the mental math gets something we're not going to do, something normal people are not going to do. Something normal people could certainly do with a calculator, but they need to know what to put into the calculator, and that's what we're working towards. So let's figure out what we did in our heads to get to that balance of $100.65. Let's write down what we know. We know that initially we put in $100. And we know that after we do something, it's going to equal 101.65. Because no, 165, sorry, not 101, just 165 cents, $100.65. Because we figured that out in our heads. So what's going on between here and here? Well, we know the interest rate's at play of 0.0065. How could that fit in there? We know we're going to keep our $100. How could that fit in there? We know that in our heads, we multiplied the interest rate times our $100, and then we added it to our $100, right? Because we know, we said we made 65 cents in interest. So at the end, it would be $100.65. That's the sum of the principal plus the interest earned. So let me show you how that can be expressed so that it will work out the same way it did when we did the mental math. And that means we can use that for problems like year 2, where the mental math is just something we're not going to be able to do. So what we had done in our heads, believe it or not, what you did in your head when you followed along with what I was saying was you multiplied 100 times 1 plus the rate of 0.0065. And I can fit that in there. That's what you did. Check it out. Commutative property of multiplication. Remember that. When you have something in parentheses, you can multiply the thing in front times each thing in parentheses. What's 100 times 1? That's easy. It's 100. Now the 100 times 0.0065, we did that. I expressed what it was as in math terms like that, but also we did it in our heads. We knew that 1% of 100 was $1. So 0.65% of 100 must be 65 cents. So 100 times 0.0065 is indeed that 65 cents. There we go. If I can get it lined up, that'd be great. So that's what we just did to figure out what our $100 would be worth in 1 year at an interest rate of 0.65%, which as a decimal is 0.0065. That's what we did. But we don't just have it for 1 year. And that does not mean it makes 65 cents a year. Why doesn't it make 65 cents a year? Because at the end of year 1, you don't just have $100 making 65 cents a year. You have $100.65 making the interest rate of 0.0065 or 0.65%. That 65 cents collects interest too now. So you can't just say it's 65 cents a year. You'll be wrong. You have to have a way to find out how much you will have in that account after year 2 and year 3. But you do have a way because you just did it here. You just have to step it up just a little bit to be able to apply it year after year, or to develop a formula to apply it all at one shot, which is of course where we're going. So let's explore what we could do to find out how much would be in that account at the end of year 2. As I just said, you now have an initial amount, a principal amount it's called, of $100 $1,001.65 because this is what we have at the end of year 1, so it's what we have at the beginning of year 2. What we did here is the same. This still applies because you still get the same. It's a fixed interest rate on a certificate of deposit. It's not changing, so you're still going to get 0.65%, which is 0.0065. And what you did here will still work the same way as it did in year 1. So you're going to multiply that by 1 plus the rate of 0.0065. And that will equal something that I'm not going to do in my head, but I already did before I started this, 101.30. Which is so small of an interest rate, it actually happens to be 65 cents a year. But that won't work with bigger interest rates. So in year 3, we could do that again. We could multiply 101.30 by 1 plus 0.0065. But suppose we weren't just doing 3 years like this simple example. Suppose we were doing 4 years, 5 years, 10 years. I mean, there's 10-year certificates of deposit. That's a very common thing. You want to know what something's worth. You don't want to do this 10 times. You don't want to do this 20 times if it's a 20-year investment. So we need a formula to get us to apply this at any number of years or at varying rates, of course. So let's think about what we did and see if we can get to that formula. We multiplied 100 times 1 plus the rate. And then that principal that we got after year 1, starting year 2, we multiplied again by the same thing. I forgot a parentheses there. By the same thing. In mathematics, when you multiply something by the same thing, or when you multiply something times itself, how can we express that? Like, we're multiplying 100 times 1 plus the rate, and then we multiply that by 1 plus the rate again. We're multiplying 1 plus the rate again and again and again. That's how we're getting to these higher number of years. It's multiplying the same thing. In math, when we multiply something times itself or multiply the same thing, it's that thing raised to an exponent. So what we did here to get to this was the same as 100 times 101, or 1 times 1 plus 0.0065 times 1 plus 0.0065 again. If we multiply something times itself, that's squared. So this is the same as 100 times 1 plus 0.0065 squared. So guess how we can get to how much we would have in that account after 3 years. We could have taken our initial $100 and multiplied it by 1 plus 0.0065 cubed, because it's 3 years. And that tells me that we would have had at the end of 3 years. Let me quickly look here. And that would have been $101.96. So that's what we should compare to $105. Indeed, the $105 is a better deal, because if you took $100 and put it away at what you have access to or I have access to, that's what we could expect to have after 3 years, and that's not 105. So it'd be better off to wait for the 105, because that person who is offering you a better rate of interest than you can get otherwise. Now, how could we apply this thinking to other numbers, other scenarios? Well, this was the principal amount that we would have put away. So this is P, or as often abbreviated, this is the present value of the money we're talking about. So we could call it P in some textbooks, or PV is what it's called in others. It's principal, or the present value of the money we're speaking of. We multiplied that by 1, because that's how we got that part of it in the account at the end was by multiplying it by 1, plus the rate of interest that we're talking about. And that's expressed as a decimal. It has to be expressed as a decimal. So we don't put 65 there. We don't put 0.65 because it's 0.65%. 0.65% expressed as a decimal is 0.0065. And if that sounds weird, think about this. 1% isn't 1 expressed as a decimal, is it? No, it's 0.01. So when we express things as a decimal, we move over the decimal 2 places to the left. When we express percents as a decimal, we move the decimal over 2 places to the left. So that's the rate expressed as a decimal. And since we were multiplying something times itself for each year that this money is in that account, then what we can put up here is an n for the number of years that it's compounding. And that will equal the future value of that principal or present value amount of money. So that is our formula. How we get there, why we get there, and what it's good for to find the future value of money. So in our next piece, what we're going to have to do is find out, well, if we were offered something in the future, what's that worth now? So that's the present value of money. But the beautiful thing is, now that we have developed this, and hopefully it makes sense, you can use this slightly adjusted to do that task. So I'm going to stop here and make a separate piece for the present value of money.